35.2 extension. Okay, so this one we'll continue talking about the enthalpy change cycle. We're just doing with some advanced level questions. So the first one, okay, class practice 35.2. You see that this question is different from the previous one. We are having 4 equations instead of 3. So therefore, I will going to construct equation like this way. The arrow may not be fixed like that, okay, but you can see that, okay, we'll have like 4 equations. 1, 2, 3, 4. If we arrange them in a square, that will be easier for us to finish, okay, the enthalpy change cycle. So first of all, okay, you're going to write the question, these equations, okay, on the top like a banner. So we'll have like C2H5OH. Do remember, okay, put down the state symbol. And then we'll just random pick one. Say, for example, question number 2, okay? So if you do the first one will be easier, okay? But I'll just do the second one, okay? Let you see how to add one and then add all, okay? So the first one, okay, carbon, we're going to add oxygen in it. Because we got 2 carbon here. Okay, this equation, I'm going to multiply this one by 2. If you're not familiar with it, okay, you just multiply this one and write it out first. So it will be easier for you to follow. So for this one, okay, you need 2 oxygen, but you just have 0.5 only. So therefore, you need extra 1.5. So therefore, I'll have to add 3/2 oxygen. Okay, so now you make up the whole things. Okay, you have 1.5 and you have half and you have this 2 carbon. So you add up the first one, okay, you're going to have like 2 carbon dioxide. And you run this reaction for twice, okay, so therefore you have to times 2. Remember this one, okay, the zigzag line, okay, show you that, okay, that one will be the outstanding. That means you don't have any reactions, okay, in this equation. In this equation, you just involve carbon and oxygen. So this one, I'll just write it down. Direct copy will do, okay. Just reactant side and product side have the same chemical. That will be all right, okay. So the second equation done, okay. Say for example, I'm going to do the the first equation then, okay. So for the first equation, well, one thing forgot, okay, after you add this 1.5, okay, remember you have to add 1.5 here as well, okay, because you add 1, you add all, okay. So the first equation, okay, you find that, okay, with ethanol, and then you need 3 oxygen here, but we just have 1.5 here, so therefore you have to add another 1.5. So in this case, okay, I'm going to add 1.5 oxygen. Remember, add 1, add all. So you have to add 1.5 here, and you have to add 1.5 here. Okay, so now you have 3 oxygen and 1 ethanol. So for this one, you add up together, okay, according to the equation, you have like 2 carbon dioxide and 3 H2O. And because this equation is pointing towards the carbon dioxide and water, so therefore you point towards the carbon dioxide and water, and according to this you have negative 1371, okay, so it will be negative 1371 kilojoule per mole. Okay, so the first equation done, okay, and the last equation, okay, you're going to have hydrogen. Each hydrogen you have to add 0.5 O2, half O2. So now we have 3H2. So suppose we should have 1.5 O2 because each of them needs 0.5, right? So 3H2. So if you do everything correct, you will find that, okay, you have the reactant that you need, okay? So right here, okay, you just need to combine these 3 hydrogen with 1.5 O2, and then you carry out this reaction 3 times, and then you'll have the 3H2O formed, okay? So that will be the constructions of a enthalpy cycle involving 4 equations there, okay? So now we just have to combine all the equations by the Heck's law. Remember, okay, you have to write by Heck's law, okay? So for the equations, okay, the clockwise one, okay, clockwise should be here, okay? And then anti-clockwise, okay, should be this direction. So you find that, okay, the reactants, okay, the starting point will be here because all the arrow coming out. Okay, so the start point here, end point will be here because all the equation, okay, all the arrow is pointing inwards here. So this one will be the end point, this is the start point. So from here all the way, add up all these, and then okay, on the counterclockwise one will be like this way. Okay, so we just put all the things together. So delta H plus, if this one is called delta H, okay, so delta H plus negative 1371. Okay, you see that all the time I put bracket, okay, and then will equals to negative 393.5 times 2. So I put a larger bracket for that, okay, plus, okay, you have negative 285.8 times 3. Okay, so now you just need to rearrange the equation. So you have like delta H equals to negative 393.5 times 2, okay, plus negative 285.8 times 3, and then you have minus negative 1371. Okay, so by solving this, okay, you will find that the answer should be negative 273.4 kilojoule per mole. Okay, so remember several things. Okay, have to remind you. First one, okay, remember when you start doing the math, okay, so please add the word by Hackett's law. Okay, and remember you have to find the clockwise one equals to the anti-clockwise root. Okay, so that will be class practice 35.2 question 1. Okay, question number 2. Okay, it's very complicated one this time. Okay, so first of all, we write the equations at the top. Okay, and then you have like 2Fe3O4, and then have CO2. After that, okay, we're going to use the equation. So say for example the first one, okay, we're going to use Fe2O3, okay, plus 3CO. Okay, Fe2O3 plus 3CO. Okay, we got 3 Fe2O3 here. Okay, we have 3 Fe2O3 here. So basically, with the whole equations, okay, we run 3 times. 3 Fe2O3 plus 9CO. Okay, and then you have like 6 Fe, and then you have 9 CO2. Okay, so you need 8 CO and extra, because 8 plus 1 will become 9. So you have 8 CO here. So add all these together. Okay, then you have like negative 11.5 run 3 times. Okay, and then you have like 2 Fe. No, you have 6 Fe plus 9 CO2. Okay, so first equation done. Okay, and then second one, okay, second equation, okay, you're pointing towards Fe3O4 and plus CO. Okay, so maybe, okay, we have like 2 Fe3O4 here, so the whole thing maybe we run 2 times, so you have like 6 FeO plus 3 CO2, and multiply the whole things by 2, and then, okay, you have like 2 Fe3O4, and then I have like 2 CO. This is so complicated, so many C, Fe, and things like that. Okay, so for this one, okay, you need to plus 2 CO. Okay, plus 2 CO. I have 8 right there. Okay, so therefore it should be more than enough. Okay, so remember they are pointing towards Fe3O4. Okay, pointing towards, okay, Fe3O4 and CO. So you will point towards here. Okay, so I will point towards here. Okay, they change from 6 FeO plus 3 CO2, right? So this one is not producing here, so I will add the CO2 here as well. Okay, because simply I just have this to give out 2 Fe3O4 and then part of the CO. So you should have 6 CO here as well. Okay, so it will be like that. Okay, that will be the second equation. So I run this time, okay, by 2. Okay, last one will be Fe plus CO2, or it become FeO and CO. Okay, so we have 6 Fe here, 6 Fe here. Okay, so the whole equation, maybe we are using the third equation with a 6 Fe, 6 CO2, and then becomes 6 FeO and also the 6 CO. Okay, so we have 6 Fe, 6 CO2. That means you have 3 left. So if you make it up, we will have 3 CO2 left. Is it correct? You can see that, okay, it is not 3, okay, because we add this one would be 4. Then must be some problems happen here, okay. So let's check one more time, okay. So check the equation. So 6 FeO plus 3 CO2 become 2 Fe3O4 and 2 CO. I use this 2 CO. Is it really 3 CO? Okay, check the equation. 3 FeO times 2 will be 6. 2 times... Oh, this one is a problem. Can you see that? This is a problem. So this one should be 2. So if this one is 2, so 2 plus 1 become 3. Then that will be perfect. Okay. One more time. 6 Fe, 6 Fe, 6 CO2. So 6 Fe, I take 6 of it. Okay. So 6 plus, 6 plus 3. You have 3 left. Okay. So you have 6 Fe and 6 CO2 give 6 FeO and 6 CO. So therefore this one, when I combine, okay, I use up this one, I use up this one, leaving behind, okay, so you still have CO2 here. So after that, okay, you should have 6 FeO, 6 CO, leaving behind 3 CO2. So you have 3 CO2 here. Hooray! Okay, the whole equation, okay, we'll use this one, negative 0.5, and we run 6 times. So in total, okay, it should be like this. The equation, okay, should be like this. Okay, so basically, okay, you add them together. So you have like the clockwise one. Okay, the clockwise one, we just have 1. Okay, which is this direction. Wait for a while. You have clockwise one. You have this direction. Okay, and then anti-clockwise one. You have this direction. Okay, so we put them together. Delta H, that is a standard enthalpy change of reaction, so you don't know what is that. Okay, delta H will equals to negative 11.5 times 3, so this is the first one, plus negative 0.5 times 6, and then plus positive 9 times 2. Okay, and then you'll find out the answer for this one will equals to negative 19.5 kilojoule per mole. Okay, so that will be the questions, okay, that we're sharing today. So this one will be a most challenging one, okay, so please do spend time in doing this. But you'll find that actually it's not easy to write all this, okay. So next video I will just introduce another techniques which is called statement form. Sometimes statement form is much easier, okay. So maybe next video I will just tell you a little bit more about that. Just want to give you one more tips, okay, when choosing the equations, okay. So right here, okay, you'll find that, okay, the reactants, okay, you have like iron 3 oxide and you have iron 3 iron 4 oxide here, okay. Remember the name of this. Just want to remind you, this one is iron 2 iron 3 oxide, okay, because it is a combination of FeO plus Fe2O3, so therefore you have like Fe3O4 here, okay. So this one, okay, you find that these compound will be more iconic, okay. So when you try to pick up the balancing, okay, say for example, if you random pick equations and say for example I want to do this one, say for example question number 3, then you just dig into it, you find that we have CO2, okay, so therefore I add Fe here and add Fe here. Then most of the time you just make the things complicated because you'll realize that, okay, actually in this 3 equation you got many CO2 here and there. Okay, so you got many CO2 here and there. So actually, is it this equation really echoing this one, okay, you add FE here will really make sense, okay? So it will be quite difficult, okay, for you to design whether you adding FE is justifiable, okay, or justified, okay, or not, okay? So I don't prefer you to focus on the compounds that is so common here. So for the other example, for example, you in the past you see that all the time we add oxygen. So if oxygen is so common, okay, we try not to focus that one first. So what is my suggestion is, okay, when you look at this equation, the iron compound, okay, say iron 3 oxide, iron 2 iron 3 oxide, okay, or like these, okay, will be more iconic, eye-catching, then you will focus that one first. So I won't have the CO2 plus Fe like this equation. I will try not to do question 3 first. I'll try to do question 1. You see that with Fe2O3. So Fe2O3. So what you need to do, just add CO. So you just consider this CO like the O2, okay, in other questions. So you just add CO right there, okay, to start up the equation 1. Or you may start equation 2 because you see Fe3O4, you got Fe3O4 here. So I can add the CO at the back, okay, to start up the whole balancings, okay, constructing the enthalpy cycle, enthalpy change cycle, okay. So question or equation 1, okay, it won't be my first choice, okay, among these 3 equations. This is just something that I want to remind you. If you find that when you're constructing the whole enthalpy change cycle, it getting into a mess, okay, try to stop it, okay, and then get a new area and then restart the whole enthalpy change cycle, okay. That will be easier for you to do. If you find that start from equation 3 is difficult, then try 1 and 2, okay. Some time, okay, if you and use a wrong equation, okay, the whole things will be more complicated, okay, but experience can help you out for this. So this will be the answers, okay, for class practice 35.2. You can pause the video and check it. And for summary, actually I didn't teach something new, okay, I just use the tips I told you in last videos, okay. Remember, I demonstrate so much at one at all, okay. If you can make the whole things balance, okay, you'll find that, okay, it will be easy to cross-check whether you're correct or not, okay. If you find that sometimes you can't construct the enthalpy cycle, I suggest you to erase everything that you wrote, okay, and then you start up from the beginning again, okay. That will help for as well, okay. So that's all for this video. Bye bye.